All right, so we're working on assignment 2, Swyk number 1. What I have drawn is not an atomic bomb, and it is not some sort of deformed mushroom. That's true. It's true that I am not an artist. Okay, I'll grant you that one. But it's a tree. I know, you're like, what? A tree? How did he get a tree out of that? Okay, go with me on this. All right, so I've got a tree. Well, it's a 24-inch diameter tree. All right, just think of that in your mind. 2-foot diameter tree, right? It's pretty thick. You hit it with your car. Who wins? Obviously the tree. Car does not win. Because the tree has power. Now, what's underneath the ground? The roots. Okay? What I'm trying to illustrate is that a fractional exponent can be thought of like a tree. The power is in the numerator and the root is in the denominator. So let me zoom in on this so you can see what I'm talking about, okay? When you are given 625 to the 1/4 power, this fractional exponent can be split up into two pieces, the numerator and denominator. Well, the numerator tells me the power, the denominator tells me the root. So another way to write this is like this: the 4th root of 625 to the 1st. Now, that's a big enough number that you might not think of what it is, but it's got to end in a 5, if I'm being nice, and it is a 5 itself, because 5 to the 4th power is 625. Anyway, that's fractional exponents. Let's take a look at some more practice with fractional exponents. You can see right here that we have, what is it? 729 to the 1/3, that would be the cube root of 729 to the 1st. Right, I can put a 1 there if I need to, not that it really matters. But the cube root of 729 is 9 itself. You can type that on a calculator, and if you need help, remember, it's, usually you got to figure out on your machine, whichever one you're using, how to handle, finding those different roots. Now, can you type 729 caret parenthesis 1/3? Yes, you can. Now, do I need parentheses on those new style of graphing calculators? The ones that are color. No, you don't, and the reason is because it raises it up and makes it look like an exponent, so it basically takes care of the parentheses. But for any of the old style calculators or the scientific calculators, which I don't expect you to have more than a scientific here, 729 to the 1/3 will give you 9. Okay. What about if I have a fractional exponent, but I also have a negative fractional exponent? Okay, let's talk about this. Where do I put my face? I don't know, put it over here. Hopefully this is enough. So, the denominator is the root. The numerator is the power. What about the negative? I want you to notice over here that I took the negative 4/3 exponent on this question and I split it into 3 pieces. First, I split it into the root. Then I have the power. And I'm saying to you this word flip. Flip really means reciprocal. So when you say 2 to the negative 1st, really, you could write that as 2 to the 0 over 2 to the 1st. And what am I allowed to do with these exponents? Yes, subtract them. And 0 minus 1 gives me -1. Well, what is anything to the 0 power? Well, anything to the 0 power is just 1. So what it looks like is we started with 2, but since we raised it to the negative 1st power, it became 1/2. Now, does that really have something to do with this question? No, I'm just trying to illustrate the idea that When you raise something to a negative exponent, it causes the base to flip. Not the exponent, just the base. Okay, then let's look at this example a little bit closer. So we're starting with 512, and we're raising it to the negative 4/3 power. I split it into really 3 parts. First, always deal with the root first. Always deal with the root first, which the cube root of 512 is 8. Then go to the power next. Well, what's the power? The power is the 4th power. Well, 8 to the 4th power is 4,096. I know, big number. And then the last part is the flip, the reciprocal. What's the reciprocal of 4,096? That's right, folks. 1 over 4,096. So that's our final answer on this question. No, I don't want decimals. I don't want you going to your calculator. 512 to the negative 4/3 power is, and get some weird decimal. Math Excel won't want it either. So, understand, root, power, flip. You do it in that order, and I know for a fact you will do well every time. Sometimes, and a lot of times when I'm working in class with students, I don't let them use a calculator for this stuff. Now, obviously, I choose a number smaller than 512. Okay, because obviously this is, getting pretty large with the numbers for no calculator. Okay, let's see what's going on next. That's question 3. Question 4. Convert the expression from exponential form to radical form. Okay, simple, straightforward, nothing hard about that, right? You get the powers of 4, you get the roots of 9. Not much you can do different. I mean, that is the answer, folks. It's not complicated when you ask a question like that. Well, write the expression below in radical form. All right, I can do that, but they threw in a little twist, right? We got the 6th for the root. We got the 7th for the power. They threw in the negative 1, right, for the flip. So I want you to look at what I did. First of all, I changed the 6th root, y to the 7th, into a radical. Okay, got that part. Then I did the flip. I did the reciprocal. And you'll notice that it kind of just like drops down to the bottom of the fraction. Well, technically what's going on is you got a 1 there. And flips over. Okay, so now we lose the negative exponent. But that radical can be simplified because there is a perfect 6th that's trapped inside the y to the 7th. So take a look at what we have here. We've got y to the 6th that we can pull out. And we know what the 6th root of y to the 6th is. Plain old y. But then there's a leftover y that's trapped inside the radical. And so we end up with 1 over y times the 6th root of y. Now, I want you to notice in the example, or well, they didn't say it in this one. There's another example that says, do not rationalize. This is an example of one that they're not going to ask you to rationalize. We rationalize with the numbers, not with all these nasty variables. Okay, question 6. Last one for this Swyk. So you split it up. Start out with the root, the 4th root of 16. That's obviously 2. Then you go to the exponent, or the power. That's the 5. That gives you 2 to the 5th, which is 32. Then you deal with the negative exponent, which is the negative 1, which causes it to flip. 1 over 32 is your final answer. So, root, power, flip. You'll get it right. I know you will. All right, that's enough for this week.